와주시고요. 팀 이치열탄.
Can you hear me at the back? Awesome. Okay. Sorry about that. Thanks. There we go. All right. Thank you very much, Sandu and Usoft, for having me here today. And welcome to the ultimate Git Workflow. Today, I'll be showing you some of the techniques that we've worked on at Atlassian to improve our usage of Git and help us to ship software faster and smarter. So before we start, how many people here are already using Git? Show of hands. Okay, cool. That's maybe 30-40% of the room. And how many people are using Subversion for version control? 2 people? Okay, maybe 10%. And is anybody using Mercurial or HG version control? Okay, no Mercurial uses, fair enough. All right, so I'm from Atlassian. My official job title is developer provocateur, but really my role is similar to a developer advocate or developer evangelist, which is what I'm often called, or my job is often called in different organizations. I chose provocateur because I'm not really a lawyer and I'm not really a preacher. Instead, I'm just a developer who likes to write code and occasionally come and talk about it to developers such as yourselves. The other reason that I'm here speaking to you is because I'm one of the founding engineers on the Atlassian Stash project. So Stash actually started as a hackathon project at Atlassian about 4 years ago. And then we decided very quickly that we created something pretty special and we wanted to turn it into a fully fledged product that we could give to other developers to help build their own software. Is anyone here using Stash for version control? A couple of people? Okay, awesome. Hopefully there'll be more wanting to do that at the end of the presentation. So I'm from Atlassian. We're actually an Australian software company originally, although I'm based in San Francisco, in the USA. Atlassian has about 800 developers located all around the world, although most of them are based in Sydney, Australia, in a time zone just 1 hour offset from here. So most of us are Java developers, but we also have some Python specialists and mobile developers as well. And of course, a bunch of web developers specializing in HTML, CSS, and of course, JavaScript. These 800 developers are part of a large team of 1,800 software nerds. Every single person at Atlassian lives and breathes software. All we do is think about how we can build better products to help other developers build better software. So we have a large range of products. Sandra mentioned some of those before. But basically, they're all involved in making it easier to ship software more effectively. Jira and Confluence are probably our flagship products, which some of you might be familiar with. But I represent the developer tools organization who build tools to work with specifically with source code. So our kind of mission statement is to make developers around the world happier in their development work and make software development teams more productive. So as I mentioned, you ship software faster and smarter. So this is the goal of the Atlassian tools, but the reason I'm here to speak today isn't really to talk about Atlassian tools, but more about Git, which is another piece of software that Atlassian didn't build. Indeed, it's a free and open source project kicked off by Linus Torvalds, a standing member of the open source community, better known for Linux, in fact. But Git is one of the pieces of software that we use at Atlassian that has drastically changed the way that we build software. And that's why I'm here to talk about it today. Now we have a lot of time, so I'm going to be covering a lot of different topics in depth. Atlassian started to migrate to Git around about 2010, so we have around 5 years of experience of building commercial quality software products there. Today I'll be talking a little bit about why we chose to adopt Git and why, if you're not using Git, you should be considering moving to it. Then I'll talk a little bit about the different workflows that we use at Atlassian, focusing on our branching workflows for the different products that we have. Then I'll talk about the different ways that you can combine branches together. We'll talk a little bit about merging and a little bit about more powerful Git features like rebasing. Then we'll have a short intermission and we're going to play a little game. We have some mildly copyright infringing t-shirts to give away. With some badges. So we'll see how that goes. Sorry. Then we'll talk a little bit about one of Git's really nice features, the lightweight overview model known as the pull request. Then I'll cover how we do continuous integration at Atlassian, how you can use some of Git's other features, like forking, to collaborate effectively with members outside of your immediate team. And then finally, I'll talk a little bit about the Atlassian product that I used to work on, Stash. So first of all, why would you consider using Git for your version control system? Particularly if you're already using something else, it can be quite a bit of effort to actually migrate over. But Git has a huge number of features that are really, really valuable, not just to individual developers, but for the entire software team. Developers love Git because it is incredibly fast. Unlike other version control systems, Git commands typically return in under a second, regardless of how large your repository is. The other nice thing about Git is that you can use it offline. So on the flight over from San Francisco, I can continue working on my laptop and committing code, even though I wasn't connected back to my centralized version control system, which of course I couldn't do when we were working with Subversion or CDX. But Git also has some really powerful features that allow teams to be more productive. It has the D in DVCS stands for distributed, so the distributed version control system. And that allows different teams of different shapes and sizes to collaborate really effectively, no matter whereabouts in the world they're located. And finally, Git is created by Linus Torvalds, the super developer who gave us the Linux operating system. So it has an incredible amount of software nerd credibility. So that's also one of my favorite reasons for using Git. There's also another very important reason to consider migrating to Git, and that's that everybody else is doing it. So there's an element of peer pressure. Sorry, is that better up the back? Okay, fantastic. So as you look at the statistics for Git adoption, in 2015, almost 40% of teams are using Git, which is pretty remarkable considering that the version control system itself is only 10 years old. Subversion still has a fair bit of market share, but this is dropping dramatically. Mercurial, the other popular distributed version control system, is still relatively low in terms of adoption. Now, this is a bit sad because Mercurial is actually a great product, but because Git is so much more popular, we find a lot of the tools and a lot of the development best practices that come out are focused on Git. So we actually recommend going with Git as a version control system, mainly because everybody else is doing it, so it's a bit more mature and the practices are more robust. So these are the current statistics, but when you look at how they've changed over the last 5 years, it's even more dramatic. You can see that Subversion is rapidly dropping, CVS even more so, and Git is far and away the leader. So we expect to see Git overtake Subversion in the next couple of years. And it's not just small companies that are adopting Git. A lot of the time when you read technology news, you hear about small startups or like non-enterprise entities using Git and talking about how they use it for their workflows. But when you look at the people who are buying Atlassian Stash and Bitbucket, these aren't small companies. These are very, very large organizations with thousands of developers. So even if you are a very large organization with lots and lots of code in your Subversion or CVS repositories, there are still other organizations out there who are making effective use of this new distributed version control system. But it's not just because it's popular that these companies are migrating. We've done a couple of surveys at conferences that we've sponsored over the last couple of years, and one of the questions that we ask is how fast do you release your software? And we also ask them, what type of version control system are you using? And interestingly, there's a strong correlation between fast releases and Git usage. So 13% of teams that were using Git were actually shipping software to their customers daily. So this is usually SaaS application vendors who run software on their servers and manage to actually push code live every 24 hours. And you can see that 27% of Git users are shipping software weekly as well, which is impressive, compared to the centralized version control users who often take months or years, in some cases, to ship their software. But it's not just release speed that Git speeds up. Git is also blazingly fast at the command line. So developers enjoy using it. It's not just about speeding up your release process. The first reason that Git is so fast is that, as I mentioned before, the entire repository is local on the user's disk. So this means that if you run a git diff command or a git log command to see what's changed, or if you need to create a commit, it returns almost instantly because it's not calling out over the network. And this is a very different model to Subversion or CVS, where you have a repository located in your data center or potentially somewhere in the cloud, and to create that commit, you actually have to call out over the network. And that latency makes those commands very slow. But with Git, everything is on your local disk, so almost every command is faster. The only thing that's a little bit slower is the initial clone from the repository or the push, because obviously that's when you introduce that network access. But what we've found with DVCS usage is that developers commit a lot locally and then push less regularly. So the DVCS model is much nicer. So that's the first reason why Git is very popular among developers and very fast. The second reason is that Git itself
is written in C, a compiled language that is very fast. And it's written by Linux kernel and file system developers, including Linus Torvalds, who originally invented it, and more recently by Junio Hamano, the Git maintainer, and a collection of other very, very good developers who not only built Git, but they also built the operating system and the file system that it runs on. So they are the best people in the world to make sure that it runs extremely fast. And when you look at the release notes from the last few versions of Git, from say 2.0 to 2.5, every single release they had continuous performance improvements. So one of their biggest features when they iterate on new versions is to make sure that the performance keeps getting better and better, and making sure that Git scales to larger and larger repositories. Which is an important point, because there's this sort of myth that people think that Git isn't good for handling big repositories. And this is wrong, because Git was built to manage the Linux kernel, which is a very, very, very large repository. The Linux kernel 3.13 release had more than 15 million lines of code in it. Now, there are some software projects out there that are bigger than that. Maybe if you're working for software that's embedded in a car, or if you're working on, for a space agency or something, you might have a code base that is larger. But most projects are smaller than the Linux kernel, and Git works just fine for it. This, the 3.13 release had 12,000 non-merge commits in it, 446,000 lines of code added in just one release, and more than 1,300 contributors. So Git is very effective at handling big repositories. Where Git has some problems is if you have a repository that has very large binary files. So if you're committing large movies or large scientific research data sets into a repository, then Git might have a bit of a problem with that, because every time a developer does a clone, it has to pull down all of those large files. But there are some very interesting projects that are built to augment Git that solve this problem. Git Annex is one that was very popular for a while, and Git LFS is a new project that Atlassian is contributing to in partnership with GitHub that will help, that also solves the large file problem in Git. So these days, no matter what type of repository you have, you should be able to adopt Git. So don't worry about the big file problem, as they call it. If you are thinking about moving to Git in the near future, or after this presentation, if you feel inspired to migrate, Atlassian has a great tutorial site at atlassian.com/git. It has all sorts of tutorials to assist developers in learning how to use Git. It also has some suggested workflows that I'll be talking about in a few moments. But it also has some tools and scripts that you can use to convert your existing Subversion repositories over to Git. Now I'll tell you a secret. Atlassian actually used to support hosted Subversion repositories. So we actually would host your Subversion code for you. But we decided to end of life that project once we switched to Git and saw that the world was migrating to Git. So when we decided to end of life that, we offered every single company who was hosting Subversion with us 3 options. They could either migrate to Bitbucket, our hosted Git offering in the cloud. We could help them migrate to Git and run it behind a firewall on their premises. Or we could help them migrate to Subversion hosting behind their firewall. Almost everybody decided to take us up on migrating to Git, and we wrote some very effective tools and scripts to make that migration happen. And then we've put all of those tools and scripts up on this site, along with some plans on how to implement it. So if you need a hand migrating to Git, then definitely check this out. Also, Moosoft, the Atlassian partner who's sponsoring this event, are experts in Git and Stash. So if you're looking for some help in migration, I would recommend reaching out to Sang-Hoon and his team to have a chat about how to get that to work. So is everyone going to migrate to Git now? Yeah? Different requirements as well. If you're one developer working by yourself on a code base, then maybe you don't need a big complicated workflow, and you certainly don't need peer code review. But if you're working with contractors, or if you're working with a large team of 10 or 15 developers, then you're going to need to be more careful about how you structure your code and structure your workflow. So all of these different factors contribute to what makes the best workflow for your team. So I can't tell you one perfect workflow that will work for everybody here. But I can teach you the different workflows that we use at Atlassian and teach you about the fundamental important pieces of those workflows so you can design your own. At the basis of every workflow, there are two things. There are issues. These are bug fixes and feature requests and improvements that you want to make to your application. And then there is the code. These are the actual commits, or patches, or diffs that implement those features. If you're using Jira for issue tracking, then these issues each have individual issue keys. Is anyone using Jira for issue tracking? I do, yeah, obviously. Cool, okay. It doesn't matter if you're using Jira or something else, this pattern is still the same. Now, if you're using Subversion, or if you're using Git, but not using feature branching, then your code base probably looks like this. You have just one line of commits with each developer creating a new commit on top of the previous ones. And this has a couple of problems. The first big problem is that if a developer creates a bad commit that causes the tests to fail, or breaks compilation, or introduces a bug, then that's going to break the build. And if you're not branching, then that's going to cause everybody to stop work. When I used to work with Subversion, I worked on a product called Crucible, which is a peer code review tool that works not just with Git, but with other version control systems as well, like Subversion, CVS, Perforce. And we had a rule: if you broke the build by making a bad commit, then that meant the whole team had to stop work. So we had a special hat that you had to wear. And you had to wear this hat until you fixed the build, which is pretty depressing. It's stressful sitting there, and everyone in the office can see that you've got a red hat on, which means you've broken the build. And there is nothing more depressing than sitting at work at 9 o'clock on Friday night wearing this little red hat while your friends are drinking beer in the pub next door. Now the reason you have to wear this hat is because when you break the build, you're causing the entire team to go into a code freeze, which means the very next commit in the repository has to fix the build. And so all of the other developers on your team become unproductive. But this pattern also causes another problem. Here we've got two different features with the commits interleaved. And it's very hard to tell by looking at these commits whether Jira 123 is finished or whether the developer still has some more commits that need to come in before it can be shipped to our customers. We call this problem half-baked features. So if I'm a developer wanting to perform a release, I have to go around and ask every single developer whether they're complete. Which basically means that if we're using a linear workflow, if we want to do a release, we have to go into another code freeze until we're sure that all of the work is complete. Which means that our developers, again, are unproductive. So there has to be a better way than this, right? And there is. It's called feature branching. So instead of just having one long line of commits stacked on top of each other, what we can do is create a new isolated branch to do our work on. So at Atlassian, every single team does this. Every time we want to work on a new feature, we create a new branch from master, then we get that feature code complete on that branch. And that means that the tests are passing, and it's being reviewed, and it's basically ready to ship. And only then do we merge it back into master. Now this gives us two very important things. The first is that all of that work is isolated. If I break the build on my branch, it doesn't matter. Every other developer can continue working on their branches without being affected, which means no more red hat, which is nice. The other important thing that this branching workflow gives us is a stable master branch. Because we only merge when that feature is complete, then that means that every merge commit on master is potentially releasable because we know it only contains completed features, which means that our master branch never has failing builds and is always releasable. Now we use a naming convention for our branches. It's up to you whether you want to adopt this, but we find this useful. We start off with the type of branch, which can be feature for a new feature, or bug fix for a bug that we've found in code before we've shipped it to our customers, or hotfix for a critical production fix that needs to be deployed as quickly as possible. I'll talk a little bit more about the difference between bug fix and hotfix in a moment. And we use these branches for absolutely everything. So we create a new branch for every single feature. We create a new branch for every single bug, no matter how small or how big it is. We even create new branches for things like documentation changes. So some of our developer docs are generated from our source code, and some of them live in the repository alongside our source. And if we want to change some text, we still create a new branch to keep it isolated. And I'll explain why that's important in a second. But basically, we want to branch for every single thing that we're doing, all the things. So I already mentioned isolation, so that if you break the build, or if you are free to experiment on your branches. Stability, so that your releases are easy because you can release from any point on master. But the third reason is traceability. If you know that every feature or every bug is being done on a new branch, then that makes it very easy to reason about what the branches in your repository are. Every single one is a new feature. So if you're a release manager and you're trying to figure out what's shipping in the next release, you can use the git branch command with --merged to find out which branches have been merged into the tip of your master branch. Or if you're wondering how much work there is left to do, you can run git branch --no merged to show you which branches aren't yet merged into master. And then you can go and hassle those developers to get it shipped. So that's the basic idea with Git feature branching. And that's the basis of all of our workflows at Atlassian. Now I'm going to show you a specific workflow that one of our teams uses. And this is the Atlassian Bitbucket workflow. Bitbucket is our cloud-hosted Git solution, so you can, it's actually, you can sign up for a free account with unlimited private repositories if you're interested. But it basically allows you to host Git in the cloud. Now this workflow is a good example of a SaaS application, because Bitbucket is run exclusively in our data centers. There's only 2 versions of Bitbucket in existence. There's the bitbucket.org, which is the main one, and then we've got a staging instance as well. Now this is important because it means that it's very easy for us to roll out production fixes because we are the only people running Bitbucket in the world. And the basic Bitbucket workflow is a basic feature branching workflow. we branch off, well, we used to branch off master, get all of our work completed, and then merge it in once it's ready to be shipped to production. But there is one slight problem with this. These green circles represent passing builds, so we run our integration tests on every single feature branch. But sometimes you run into a thing known as an integration failure. So when we merge this first feature branch into master, we know that the tests are going to pass because we've just run them. But sometimes, when we merge a second feature branch in, the build will break. Even though those two feature branches pass independently, sometimes you can run into problems. An example of this might be if in Jira 123, we decided to refactor an internal REST resource, which serves the front-end UI. And then in Jira 456, we built a new feature that depends on that REST resource. So independently, the two sets of tests would pass, but when merged together, they would fail. So this means that instead of having a stable master branch, we're back into an unstable master branch, which means that we're back into Red Hat territory, and the developers are unhappy again. So what the Bitbucket team does is instead of merging straight into master, we create a new interstitial branch known as develop. So develop is still a mostly stable branch, but if we do get an integration failure, then we can create a new commit directly on develop that fixes those tests. This is the only time when we'll commit directly to develop, by the way. And then when those tests pass, we can merge into master. And this means, again, that our master branch is always going to be stable, which is great, because it makes those releases easier for us. One other really nice thing that this workflow gives to us is the ability to do continuous deployment. So what we do at Atlassian is continuously deploy our develop branch to our staging server. So every time we get a green build, we push that to staging.bitbucket.org, and that means that Atlassians get to use the latest version of our software continuously. So that means that we have fast feedback if we manage to break something. And then, when we're ready to push to production, all we have to do is merge develop into master, and that triggers our deployment process to prod. In fact, the way that we do that last deploy is via a pull request. So we create a pull request from develop into master, and then once we've signed off on those changes, we hit merge, and master is deployed to production. If you're confused about what a pull request is, don't worry, I'll cover that in a little bit. So this covers the basic feature and bug fix workflow, but there is one thing that we need to cater for, and that's when we find a critical bug in production, and we need to deploy a thing called a hotfix. So hotfixes are really, really important things that we need to merge and deploy as quick as possible. So we handle this by, instead of branching off develop, by branching directly off master. Then we do our fix and make sure that it's working. And then, because we want to test it before deploying to production, we deploy it directly, we merge it into our develop branch, and this gets deployed to staging. Then we can test that the fix is effective. And then finally, merge into master. Now the reason we merge directly into master rather than merging develop into master is because there's potentially been some other work done on develop that we haven't tested enough and don't want to ship to production just yet. So this allows us to very quickly patch master without having to worry about untested work. And Git is smart enough when we do merge develop into master later on to figure out that that commit has already been merged and it won't reapply that diff. So this is an example of a SaaS workflow that we use at Atlassian. Now I'm going to talk about another product's workflow, Atlassian Stash. So unlike Bitbucket, Stash is a piece of software that we ship to developers and engineers all around the world. So it runs in different data centers. So there are tens of thousands of Stash instances out there. And this means if we roll out new features or new bug fixes, then it can take a long time for those changes to be deployed. So this workflow is kind of similar to a workflow that would be useful if you're a mobile developer, a desktop developer, or an on-premise server developer like Stash. So the big difference with this kind of workflow is that you need to have stable release branches. And this is so that if a customer has to upgrade to get a critical bug fix, they don't have to jump a major release version. So if they're on 1.2, they don't want to jump to 2.0. They want to upgrade to 1.3 to be safer. So the way that we do this is that we continue to develop on master with our new features, and then when we're getting ready to perform a release, we create a new release branch named after the version that's going to be released. So here we're branching for our 1.2 release, which we might release next week. Then we harden on that branch. So the only branches, if developers are working on 1.2, they branch off 1.2 and merge back into that. But if they're working on a future release, say 1.3 or 2.0, then they continually branch off master and merge back into that. So this works well. The only tricky bit is when we've got a bug that we find in a released version of our software. So say we ship 1.2 and we find a bug, then we need to branch off 1.2, fix the bug, and then merge it back in. But then because we also want that bug fix to be in future versions of our software, we also have to then merge 1.2 into master. And that works fine when the bug is in the most recent version of our software. But what happens if we find a bug in 1.1? Well, probably guessed it. We branch off 1.1, then we merge back into 1.1 once it's tested, then 1.2, and then master. Simple, right? The only problem is that this is boring. Developers have to remember to forward merge each version. And if you're working on software that has 10 supported versions, you're going to need to do 10 merges, which is not just boring, it's also very easy to forget about one of those supported versions. And if you forget to merge 1.2 into master, then that means that bug fix isn't going to be in future versions of your software, which is a massive problem. So in Stash, we've actually built this feature to do automatic merges. So if you have multiple release versions, supported release versions, and you create a pull request targeting an earlier version, it will suggest that you can automatically merge it forward. And when you hit the merge button, it will actually do that for you. So this can saves developers time, but it can also save you accidentally regressing a bug fix that you've done. So that's two of the different workflows that we use at Atlassian, and most teams use some variation of that, depending on whether they're working on a SaaS product or an on-premise product or mobile app. So now I'm going to talk a little bit about merge strategies and how you can combine work that's being done on two different branches. So we've been talking a lot about merging, and a merge is basically creating a commit that unifies two branches together. So the way that Git actually stores data on the file system, or the logical way that it stores it, is that each commit references the entire source tree of your repository. So our feature branch, that last red commit, has all of the changes that have been done on that branch. And the new commit that we created references a source tree that is the entire, fantastic, okay, cool, maybe 10% of the root. So rebasing is unique, is where you choose a different place to create your feature branch from. So you're basically going back in time and pretending that you created your branch from a different commit. This is one way of doing a rebase. So what it looks like is this. It looks like your commit was created from a different parent. Now, conceptually, this is similar to if you were using Subversion, and instead of merging a branch in, you unwound all of your commits and stored them as individual patch files, and then checked out the develop branch, and then reapplied each of those patches on top of it. That's basically what's happening with a rebase. Now, this has a couple of interesting implications, and in this case, what we're doing is a rebase to update our feature branch. But you can also use a rebase to push your changes back onto the main branch. So, say we had a feature branch, we could actually replay these commits onto develop as a rebase. And what this means is that we've combined our two branches, or all of the work done on our two branches, without creating a merge commit. Some teams prefer this because it means that you don't have any branches in the history of your repository. You just have one long line of commits. And again, you can think of it conceptually as taking individual commits and then reapplying those diffs or patches on top of your master branch or on top of the branch that you're rebasing onto. Now, there's also a feature of Git known as an interactive rebase, which is pretty cool. When you run the rebase command with the -- interactive flag, and you specify a range of commits that you want to combine or move onto a different branch, it will show you a list of all of these commits in your editor and then allow you to specify what you want to do with them. So with this, instead of just moving commits around, you can actually rewrite those commits as you replay them, which is something that's impossible to do in Subversion. These are some of the commands you can use in an interactive rebase. Pick basically just leaves the commit as it was. Reword lets you change the commit message. So often if I misspelled something in a commit, then I'll use the reword command to change it. Or if I'm rebasing a feature branch onto develop, sometimes I'll be a bit lazy with my commit messages while I'm developing, but this gives me a chance to write beautiful poetry in my commit messages. Edit is really powerful. It lets you actually change the content of those commits as you go. So I don't use that very often, but if you made a mistake in your code, you can actually erase that from history. Squash, I'll talk a little bit more about later on, but Squash actually combines multiple commits together and then concatenates the different commit messages. And that's very useful if you want to make every commit in your repository actually represent a single feature. So this means you can have a very concise history of patches that only show kind of the final result of your feature work. But it can be a little dangerous because you actually lose information when you perform a squash. All of those interstitial commits disappear. Fixup is actually the same as squash, but it doesn't combine the commit messages together. It just leaves, it takes the most recent commit message. And exec is another powerful command you can use to actually run scripts during the rebasing process. Now, I haven't used that myself, but I think the idea is so that you can actually run tests against the resultant code after you've done edits and done squashes. To make sure that your code actually still works after you've rewritten it. Has anyone used the exec command with interactive rebase? Okay, so hoping I could learn. Now there is one very important thing to know about rebasing, and that is that, as we've discussed, it rewrites the history in your repository. And you have to be really careful about when you do this. In fact, you should never rewrite history that's already been published. And when I say published, that can depend on your team. If you are using a feature branching workflow, then sometimes it's okay to rebase a feature branch that's been pushed to the server, but probably not if you're working with another developer. And it's never okay to rewrite the master branch or the develop branch of your project if you have more than one person on your team. And I'll show you why it's a big problem. The way that Git thinks about commits is in terms of their SHA, which is a commit hash, which is a unique identifier for the commit. And the SHA is the long hexadecimal, 40-byte hexadecimal string that Git uses as an identifier. Now, that string is actually created by hashing the contents of the commit, which is the date that the commit was created, the author's name, and then all the commit message, and then the entire tree, the source tree of the repository at that point, and all of the previous commits in the history of your repository. So if you go back and change, rewrite part of the history of your Git repo, then it's going to rewrite every single commit going forward from there. And this has some big repercussions when it comes to doing merges, because Git uses these individual shards to figure out which commits need to be part of a merge. So for example, we've got 2 developers here working on master, and these are their local copies of master in their local repositories. Now say Bob has just written a Postgres adapter for his application and pushed it to master. And then he decides that actually he doesn't want to use Postgres. He wants to use MongoDB instead. So he rewrites his adapter to use Mongo. Then he decides to push it to the server, and Git will actually stop you at this point and say, you're trying to do a force push to the server. You're trying to rewrite history on the server. This is probably not a good idea, and it will fail. But you can force it to do that by passing the -f command or -- force. And that will rewrite what's happened on master. And this is okay at this point, but if Alice has done some additional work and tries to push to the server, she's also going to get a rejected message because she doesn't have that new commit from Bob. So at this point, she's going to do a pull. And this will create divergent history between what her local repository's master is and the remote's master. So what Git will then do is create a merge commit. And here we have a big problem, because now we have 2 different commits that were originally rewritten but have been reapplied to the codebase by Alice's local changes and Bob's rebased commit. So what this means is, in my example, we have now a Postgres adapter and a Mongo adapter inside our codebase, even though Bob tried to delete the Postgres one. And there's all sorts of ways that this can potentially impact your software depending on what you're writing. You don't need to remember all of that. You just need to remember that that's really bad. So, in general, rebase is very powerful, but make sure that you never rewrite history that's on a shared branch, like Bob and Alice just did. So we've talked a little bit about merging and rebasing. And I just want to summarize the different ways we have of combining branches. The first is the merge commit. As we mentioned, this is the most simple and straightforward way to combine branches. Then we have a rebase, and this is known as a fast forward because instead of creating a merge commit, you can literally update master to point at a new commit. And sometimes this involves rewriting history by doing a rebase, and sometimes if master hasn't changed since you created the feature branch, Git will actually just do this automatically for you. The reason it's called a fast forward is because a branch in Git is actually literally just a file named after the branch, and that file contains a shard which references the commit that it's pointing at. So this is partly why Git is so fast with branch manipulation, because all it's doing is changing that file. But to update master in a fast forward manner, all we do is say, hey master, you now point to this commit. We're not actually changing anything about our repository structure. There's also another common way of rebasing using that squash command that we looked at. So one really common pattern is to take your feature branch and then apply the squash command to every single commit on it. And that means that you just end up with a single commit that represents your feature branch. Some developers and teams like this because it makes your commit history very, very easy to read. You don't have a lot of small commits, you just have big feature chunks. So if you're trying to determine what workflow your team should use, you might be wondering which of these is the best. I'll just sum up the different benefits for you here. The merge commit, some people say it has an ugly history because there's sort of lots of things going on. You see every commit from every developer. But this is pretty valuable as well because you have full traceability. You can go back and see individual diffs, which can be useful if you're trying to track down a bug. The other good thing about merge commits is they are inherently safe. There is no chance you can lose history, unlike with a rebase. Fast forward rebasing, some teams really like this because of the clean history, as we mentioned before. But it's still fairly verbose. You can still see every commit. They've just been rewritten a little bit in how they've been applied because there's no merge commits. We're pretending that each feature was written in sequence. And then finally, there's the squash rebase. Now, the squash rebase makes your commit history very pleasant to read, as we mentioned, but if there was a subtle bug that was introduced in a commit, you've lost all the information about how that bug got written in the first place. But some teams like that as well. Now, when it comes to Atlassian, we're actually, as I mentioned, we have 800 developers, so we went for the hardest to screw up option. Because at the end of the day, when you're developing in a professional context, it's very useful to have that full traceability so you can go back and think about how a developer evolved a feature. However, we do allow developers to rebase their own feature branches if they want to. But probably only about 20% of Atlassian devs actually rebase. Most just commit and then merge. Mainly because it's simpler. So you don't have to follow this, but it's working fairly well for our team. Okay, so we've been talking for quite a while. Now we're going to have a quick intermission. And we're going to try playing a little game. And the game is called Git Trivia. Now I know not everybody is using Git, but that's okay. We're going to ask a series of questions, and each question will have 2 possible answers. So maybe we'll just do a quick practice round to make sure everyone gets it. And then the winners will get a free t-shirt of their choosing. So can I get everyone to stand up? Cool. Okay. So this first one will just be a practice. So we won't. No one will go out in this first round. So what's going to happen is there'll be a question up the top, and then there'll be 2 possible answers. Now, the question is, which hashing algorithm does Git use to generate those commit IDs? And the answer will either be SHA-1 or MD5. So these are 2 different popular hashing algorithms. If you think it's SHA-1, then you can put your hands on your head. And if you think it's MD5, then you should put your hands behind your back. And then I will reveal the answer, and anyone who gets it wrong has to sit down. So the answer is SHA-1. Nice. Okay, almost everybody got it right. So even if you're not using Git, there's only 2 possible answers. So you've got a pretty good chance. Just flip a coin. Okay, so now it's for real. The next question is, the git checkout command can be used to check out an existing branch. Is this true or is this false? So if you think it's true, put your hands on your head. And if you think it's false, put your hands behind. Okay, and the answer is true. You can use the git checkout command. So if you got it wrong, you might have to sit down. Okay, cool. Next question. The git checkout command can be used to create a new branch. Is this true or is it false? The answer is true. If you pass the -b flag, you can use it to create a new branch as well. Okay, still got a lot of people. Okay. The git checkout command can be used to check out a file. Is that true? Can you check out a file with git checkout? Or is it false? There's no need for branches. Okay, got a pretty good split. True, again, you can use git checkout to check out a file. So if you've modified a file and you decide you don't like your changes, you can run git checkout -- file name to revert those changes. So Git obviously follows the Unix philosophy of doing one thing well. Or not. The git checkout command can be used to create a new tag. Can the git checkout command do everything? Or is this false? Can it not create a new tag? Alright. The answer is false. Sorry. Oh, tricky. We've got a few people left. About 10 players remaining. Okay. Enough about the git checkout command, I think. So, what is the purpose of the git ignore file? Does it let you ignore different line endings if you're maybe developing with Linux and Windows? Or does it let you ignore files with certain names in your repository? Head if you think it's different line endings, or tail if you think it's files with certain names. It's files with certain names. Very close though. The git attributes file lets you ignore files with different line endings. Okay, so the git DAG is the data structure that Git uses to store its information. And it's an acronym. Does it stand for Directed Acyclic Graph? Or does it stand for Data Agnostic Graph? This is tricky. Is it Directed Acyclic Graph? Or Data Agnostic Graph? Direct acyclic? Data agnostic. Okay. The answer is Directed Acyclic Graph. So this is technically, when you look at your commits, all of those branch diagrams, it's directed because each commit references its parent, but it's acyclic because you can never have a commit reference in a circle. Do we have 4 players left? Okay, you guys all get t-shirts. But let's go to the end just to see. And the final winner will get my lucky red hat as well. I'm trying to get rid of this thing. Okay. In Git, what is a merge with more than 2 parents called? Is it a Hydra merge? Or is it an octopus merge? Heads for Hydra? Or tails for octopus? Answer is an octopus merge. Oh, pretty. Oh, but you guys get t-shirts though, so remind me to give you a voucher at the end. Alright, 2 people left. Okay, so this is getting fairly technical in terms of the Git data structure. Creating a new branch from a 40 megabyte working copy, how much disk space does it take? Is it a little bit? But if you're new to pull requests, These are some tips that a gentleman named Mark Seaman, whose handle on Twitter is Plo, came up with. And I really like them, so I'm just going to go through them quickly now and how they apply to us at Atlassian. So he numbered his 10 tips, and I've kind of grouped them into how I think about them. Now, the number one rule for pull requests and feature branches actually in general is to try and keep them as small as possible. So do little incremental features or parts of features. Now, the reason for this is you want pull requests to be a lightweight process. If you're trying to get reviewers to review your code quickly so you can merge it to master quickly, the smaller and more concise it is, the easier that is to do. So your pull requests should be small. They should do one thing and one thing only. So try to resist the temptation to improve other bits of the code base on that branch. If you need to reformat something, or if you find an incidental bug that you need to fix, try creating a new branch for that instead. As we covered before, branches are very, very cheap in Git. They're 40 bytes. So creating a new branch to fix that doesn't cost a lot in terms of your effort or in terms of the repository overhead. And this is very different, again, to Subversion, where branches are very, very heavyweight. So typically try to, as we said before, create a new branch for every little thing that you do. And that will help the pull request process, because instead of 100 files to review, your reviewers will only have 3 or 4 or 5 files, depending on the feature. The next is one that trips people up sometimes, and this is that you need to watch how wide your lines are in your repository. Now, this is common sense for any code base, even if you're not using pull requests, because it's much easier to edit lines that are 80 characters long or 110 characters long than an entire Python file that's written on one line. But it's especially important with pull requests because the output from the git diff command is line by line. So if you have a line which, if you have the entire program on one line, then when Git does the diff, it's going to look like you rewrote the entire thing every single time. So keeping your lines at 80 characters or 100 characters makes it much easier to review. The next set of tips that Matt gave us is that basically your code should be fairly complete by the time you create the pull request. This means that it should compile, if it's a compiled language. Your tests should be passing, and hopefully you've added additional tests to cover the new functionality that you've created. How many people use continuous integration here? So write tests for their code base. Okay, cool, a few people, good. So assuming you're writing tests, you should be adding new tests as you add the features. And that will be automatically part of the code review as well if you add the tests on the same branch. And this is useful because test code is important, and you want your developers to be reviewing the test code that's written while they're reviewing the feature. Because that means that not just that the test code works, but also that the developers can check that you've written enough tests. And one of the bits of feedback that I get on my reviews is, Tim, you've forgotten to test this feature properly, write some more tests. Which is good, because it means that we have a more complete coverage of the code base. Now, Atlassian Stash actually makes sure that you've done all of this by preventing you from merging the branches together until the build has passed. You can turn that feature off if you're not using tests, but it's very useful if you are running with a continuous integration server. And you can also do things like create a code coverage build that makes sure that the percentage of your code base that's covered by tests doesn't decrease on your feature branch. So that means you can continually improve your code coverage. Another important tip for pull requests is that you should make your reasoning behind your code as clear as possible. Now, there are a few ways to do this. the best way is to make sure that your code, the code you write, is readable. So that means good variable names, use common design patterns, use shared libraries of code to solve problems that have been solved before. That way, the more familiar the way you've solved the problem is to the developer, the easier it will be to review, and also the easier it will be to maintain that code in the future. Now, if you can't write the code in an obvious manner, and you have to do something slightly tricky, or something slightly unorthodox, then sometimes you'll want to write comments in your code to explain it. Now, ideally, you should be using, this is kind of a personal preference, but I think it's generally a good way to do development. Typically, you shouldn't be explaining the obvious in your code comments. You should only be using code comments when you've got something that's maybe a little bit confusing or you have to explain. What you can do as well, and this is sometimes acceptable, is explain it in your commit message. Now, often if you end up having to explain why you've done something in a commit message, that's an indicator that you should be either refactoring the code to make it more obvious, or writing a comment in the code. And this is because it's more discoverable if it's actually in the code. But because the commit message is pushed around with your repository, because it's stored as part of the commit metadata, sometimes a commit message is okay too. And the final place where you might want to document your reasoning is in the pull request itself. So PR comments are sometimes useful if you've got code that maybe conforms to a common pattern, but you need to explain to the reviewer, who might be a junior developer, what that pattern is. But often if you find yourself explaining your reasoning in a pull request comment, or if someone asks you a question in a pull request, and you realize that maybe your code isn't that clear, then that's an indicator that you should be going back and changing the code rather than just replying to that one person. Because the chances are, if one developer finds your code confusing, then other developers are probably going to find it too. So the idea is to feedback. Like if you find yourself writing explanatory commit messages or writing detailed comments, go back and think about your code and inline comments first and see if you can move that information back in there. And of course, the git rebase command means you can go back and actually rewrite that history if you like. Now this one is kind of obvious, but it's good to call out. And that's that you should be writing your code well, but you should also be writing your comments well as well. So don't just write a code comment that says, "I'm sorry," or "sad face," or "this is a huge hack." Try and write comments that sort of explain why you did something the way you did it, particularly if you've done it in an unorthodox manner. Because I've come across those comments when you find a bug in your code and you run a git blame command, and it turns out that the bug was introduced in 2008, and then the comment immediately above is, "This shouldn't work," or "This is horrible." And then you think back to that 2008 developer and say, you could have potentially written something a little more useful there. Now, the final bit of advice that Matt offers is to avoid thrashing. Now, thrashing is where you've got a series of commits that do a bunch of different things on your branch, and a reviewer decides that they like most of what you've done, but that these two different commits probably aren't appropriate on this branch, or maybe just aren't appropriate at all and should be removed. Now, in the bad old Subversion days, the way that you deal with this is by creating a new commit that removes those problematic changes. But in the new Git world, rather than creating a new commit, what you can do is actually run the git rebase command and remove those commits from history before you do the merge. And Matt recommends this as a way to keep your commit history clean. And I tend to agree. But again, only if no one else is also working on that branch. Because if someone else is working on that branch, and then they attempt to push to that branch after you've rebased, then all of those changes are going to come back in again. So, yes, only do it if it's non-shared history. Now these last 2 points are points that are exclusively to Atlassian. Are ones that we put up in Atlassian. And these are both to do with teams. The first is to avoid flame wars. I'm not sure how well that translates, but basically you need to avoid having very, very long arguments on a pull request, because sometimes two developers are just going to be opposed to how a particular problem has been solved. And this happens everywhere. So kind of the rule of thumb is that if you have a comment thread that's more than 5 deep and it's looking like an argument, then at that point you should go and talk in person about what the problem is. And often when you talk in person, it's more effective than kind of the commentary. Sounds strange, I'm a Stash engineer telling you not to use Stash for a discussion. But and if in person you can't resolve the discussion, then probably what you need to do is escalate it to your team's architect, or if you're both architects, and this doesn't happen very often, then you should escalate it to your director of engineering. It can be often useful to get a perspective from another engineer. And it doesn't necessarily need to be a higher level engineer. Architects are useful because they can bring more perspective. But even just another developer to sort of ask them what they think is the most appropriate way to solve the problem. And the last tip I want to give you is to set a team policy. Now there's 2 parts to the policy. The first is deciding with your team what you need to do as part of the pull request process. Some teams will be okay with you just reading the code. Some teams will actually ask you to run the code and actually do some physical testing of the application to make sure that it works. And the second part is to actually make sure that all of the different requirements for your pull requests are enforced. So Atlassian Stash actually has this concept of merge checks, and these can be configured at the repository level. And you can basically say, I need to have 2 approvers for a pull request. So there's an actual approve button in Stash that you press once you're comfortable with it being ready to be merged. And until 2 people, so this is the way we do it for the Stash team, until 2 people have approved the pull request, it is not allowed to be merged. And Stash physically won't let you press the merge button. We also have a rule that all of the continuous integration builds must be passing. And depending on the project, that could be between 1 build and like 12 builds. And also we have another rule that if the pull request changes, then reviewers have to come back and sign off on those new changes. Now this one's a bit contentious. The Stash team actually no longer requires this. We trust our developers to only make improvements that are minor in nature on top of the PR. But depending on potentially what industry you're working on, this can be very important for developers to actually physically sign off on every single part of the diff. So that's all I'm going to say about code review. I hope that some of you who aren't doing code review maybe now consider that it might be useful. And now let's move on to talking about continuous integration. So the traditional wisdom with continuous integration is to build your master branch or your develop branch or trunk if it's with Subversion, because that's where all of your feature work is integrated. Hence the term continuous integration. Now, with Git, what we've started doing is building all of our feature branches as well. As we mentioned before, this allows us to make sure that our tests are passing before we merge back in. Many continuous integration servers support this feature branching workflow. If you use Atlassian Bamboo, which is our continuous integration server, There's a checkbox you can check to say build my branches as well. So it's very straightforward to configure. And it will also track who owns each feature branch, which is useful. One thing you need to consider with feature branching as well is where you create your feature branch from. Now, typically, you'll create your feature branch from the tip of master. But sometimes you run into problems with this. So we've actually created, this is the create branch screen in Stash. Now this might seem a little bit weird for some Git users, because you're typically used to creating a branch locally on your local disk and then pushing that to the server. But we also allow you to create it on the server side for two very important reasons. The first is that we can pre-populate the branch name based on the Jira issue you're working on. So you can actually, if you've got Stash integrated with Jira, you can click Create Branch on your Jira issue, and it will take you to Stash, to this screen. The second reason is this little tick. This is a tiny little 32 by 32 pixel image showing us that the master branch is currently green. Now, as I mentioned before, the master branch should always be green, but it depends a little bit on your team workflow as to whether that's true. But this is really, really important. The reason why this is important is imagine we've got a developer who comes in and should create a feature branch, but decides that for whatever reason, they're not going to do it. They're going to make a tiny little change. It's just a little bit of JavaScript in the UI, and they're going to commit straight to master. And predictably, they're going to change something that's going to make an integration test fail. And they'll see the build fail, realize that they've made a little mistake, and go in and fix it straight away. This might only take 10 minutes. But for those 10 minutes, there was a broken build on master. And then they disappear. Now you might think that this is okay, because our master branch is green again. But if you're unlucky, and you're another developer, and you create a feature branch off that broken commit, say this developer is doing something different. Maybe they're changing something in the database layout, or the ORM layout, and they make a tweak. They commit and push to the server on a feature branch like they're supposed to, and then their build breaks. But it doesn't break with a database test, or an ORM test, or anything in the Java layer. It breaks with a JavaScript UI-based test. And as a developer, you're going to look at those test results and go, like, logically, you'd say, okay, I couldn't have possibly caused that failure. But as a developer, you're going to look at that and go, holy crap, how did I cause that to fail? And you're going to go back and try and reproduce it locally, try to figure out how this database change managed to cause a JavaScript UI test to fail, and you're going to freak out about it. And then finally, you're going to go back through your build log of master and realize that that commit was broken when you created the branch. But you might have lost hours of time by that point. So that's why that little green tick is super important, because it means that you're starting from a solid foundation when you first create your branch. So that's continuous integration. If you have a look at our Atlassian Git microsite, it talks a little bit more in depth about our setup, but really all you need to know is that running continuous integration builds on your feature branches is a valuable thing to do. And including it in your pull request information is valuable as well. So now I'm going to talk a little bit differently about some of the more advanced features of Git in terms of collaboration. Now this might not be appropriate for every team, but it's kind of interesting to see and good to know in case you come into a situation like this. Now, collaboration is interesting. When you're working with a small team or by yourself, it's relatively straightforward. But if you're working with a distributed team, or maybe with developers outside of your organization, then you can run into trouble. Now, contractors are good. I've worked with contractors before, and sometimes they're fantastic. Sometimes you can run into problems though because you're bringing in new developers who might not be familiar with your code base. So testing for integration or support members who are contributing bug fixes or problem. Now, if you're collaborating with these external people using Subversion, it's pretty painful. Traditionally at Atlassian, when we were using Subversion and we engaged a contractor, we'd basically give them direct access to our Subversion repository.